Get. Hey, I am gonna give you a really short intro into electric potential, otherwise known as voltage, otherwise known as potential difference. But hey, we did problems like this where, hey, you know what? I am going from, let's say I have a hill and I have something sitting on a hill at point A and it's going to go from A to B to C, back down to D or whatever. And let's say I'm just going from A to C and you're doing an energy problem. So if we're doing an energy problem, you would say, well, at A, I have potential energy, and then at C, I have kinetic, and I have also potential energy. But if I wanted to solve the speed, you'll notice what's really important is not the mass. It is this idea of the change in potential. So sometimes we call like this G times the change in height gravitational potential. So if you like gravitational potential, it would be the potential energy over the mass, okay? But we've done lots of problems, or you guys have done lots of problems with that last year. So let's say we have a charge, okay, and a charge is fixed in place. And I'm going to have another charge go from A to, I don't know, let's say C again. Well, again, it doesn't matter how much charge is at A and going to C, we could still solve the problem. Except the electrical equivalent is going to be electric potential, which is going to be the energy per charge. Electric potential is also called voltage, so there you go. All right. So here's what I mean with this. So let's say I have my spandex here. There is a hill in the top. Well, if I say I'm going to go like from this point here and I'm going to roll down, or go from this point here and roll down, hey, guess what? The speed at the bottom is the same. Why? Because it's not the mass of this that determines the speed. It's the change in G times H that determines the speed. And that's going to be the same thing with charges. We're going to be using this later on, but you could use this to represent a positive charge. And then you'll notice any point along here would have the same potential, okay? If we're talking about gravity, it would have the same gravitational potential. If we're talking about charges, it would have the same electric potential. So hopefully that makes sense, and you should be able to do the two problem pages in your packet. Book it!